There are a number of building blocks for digital electronics, and these building blocks come in the form of gates. We're going to go over two logic gates today. One is called an OR gate. OR gate. And that, the symbol that you use, one second, the symbol that you use for this looks like this. It's kind of a, I don't know, back to front crescent moon or something like that. And an OR gate has two inputs and one output. And the output is going to depend on the states of the inputs. Now we've gone over it before, but in digital systems, the signals are ones and zeros. They are essentially a high and a low. The high being a 1, the low being 0, close to 0. And what that looks like in terms of a signal is that they say this is just generally a signal. Okay. So depending on the clock pulse, this would be considered a 0 because it's low. This would be considered a high, 1, low, high. Of course, we don't always switch between low and high. You can have, a couple of zeros in a row. Okay, so that's the signals that would be going into an OR gate, into gates. So what is the output depends on the input, and this is generally shown up on what's known as the truth table. I guess because it tells the truth. Okay, you have two inputs, one output. So you could have, there are different combinations that you could have. You could have both inputs as 0. You could have either one of these inputs as 1. Or you could have both inputs as 1. So for an OR gate, what would the output be? So for an OR gate, if there are any ones at the input, there's going to be a 1 at the output. So if both of the inputs are 1, there's definitely going to be a 1 at the output. But also if either input is 1, there's going to be a 1 at the output. The only time that there is a 0 at the output is when both inputs are 0. Okay, so that's the truth table for an OR gate. Now let's have a look at a question. So say A and B, this is kind of how it looks usually, a question. The A and B are the inputs and something like X is the output. Now you won't get zeros and ones explicitly at the input. What you'll get is something like this signal. So this is 0 and this is 5. And remember that when it's high, it's 1. When it's close to 0, it's 0. So for B, okay, so these are the inputs. So what are we going to see at X? What's going to be shown? Okay, so I find it helpful to first mark where there are changes, because that's where we can potentially have changes at X. Okay, and you can even, it depends on what you want to do, you can even write in, all right, so this is 1. If you want to, no pressure from me. Okay, so what is the output going to be? So using our truth table, we have a 0 and a 0. You're going to get the output as 0. Okay, so this is the 0. Now here we have A is 1 and B is 0. So it's this on the truth table. So the output is going to be 1. So it's a change and 1. Now at this point here, both inputs are 1. So it remains 1. Here B is now 1. So, oops, this is B, this is 1, this is A, so we still have 1. Okay, here they're both 0. So it goes down to 0. And now A is back to 1, so we go back up to 1. Here they're both 0. Here B is 1, so it goes back to 1. So this is what X is going to be. This is what the output is going to be for this OR gate.